welcome back. In the last lecture, we derived Euler integrated fundamental equation. We will continue this exercise. In this particular lecture, I will start with legendary transformation. Okay, this is quite relevant or rather important. The reason being is that though our natural variable, for example, for u is SVN, okay, though it is possible to control in principle this variable, but this is much more difficult in practice. The much more common variables which often used is temperature, because you can easily put your system in a controlled bath and maintain the temperature. You can also maintain the pressure by keeping it open to the atmosphere. So thus the common variables which are of interest to us, which we can control much easily, is constant temperature and pressure. Okay. Now temperature and pressure appear as a first derivative of the fundamental equation of u. Okay. So in other words, if we want just a function u as a function of t, Pn, this is possible. However, this will not have the same information as in the original function. Okay. So we will not have the same information, thus we rather not use it. So one of the reasons is, if we use integration in order to get such a function, we get a constant which is ambiguous variable or ambiguous and cannot be assigned certain information, and thus we lose the information by simply trying to use integration, and I will try to explain it by a simple example. So let us assume that we have just one function variable, or one variable based function f of x is x to the 2 plus 2. So now we are going to construct a function. So we are going to construct a function f of w, okay, such that w is the derivative of f, okay. So which means basically w is df by dw, which is nothing but 2x, okay, or this means x is w by 2. So f of w is going to be w square by 4 plus 2. All right. Now we are going to attempt to recover original fx, okay. So that's our objective now. So w is nothing but the derivative of the function. So let's say this is y, okay. Now so w is a function, so what we are going to do is, let's assume that this is y, which essentially means w is 2y minus 2, right. Now this w itself is also can be written as del x by del y. This is nothing but w, okay, which is can be written as x is integral of w y, and now w is back here. We plug in here, we get okay. This is equivalent to saying y minus 2 plus c, or in other word y is x minus c square plus 2. So this unknown integral constant constants are introduced here, okay. So, by simple integration we are going to get unknown constant, which means that we are not going to get the original function recovered here. So, which means this is not appropriate method in order to extract or change the variable, okay, because in this method we are not going to retain the information as we change the variable. But there is another method which allows you to do that, and that is what we are going to use it, that is called Legendre transformation. So, let us again assume single variable. For a single variable f of x, our objective is to obtain a new function g of w, let us assume that, with the same information as in the original function, but expressed in a new variable. So, what is the variable? W, which is a derivative of x, okay, first derivative of the original function. And same information means is equivalence is something which we can, which means we can recover original function. So, we can recover original function without any integration constant, okay. So, that means can be recovered from the transformed one without any ambiguity. Okay, which will be in the without any ambiguity in the form of so the equivalence is basically can be that we can recover the original function from the transform one without any ambiguity in the form of integration constant, okay. So, this can be done through mathematical operation which we are going to say, or which we are going to describe subsequently, Legendre transformation, okay. So, I am going to prove it for only single variable. So, let us assume that so you have this GW, which is basically a transform function. So, we are going to write it this as the original function minus x multiplied by first derivative of the function f, that is x multiplied by w, okay. So, this has the following property with the following property, okay. So, first of all, df is w dx, right, because that is by definition we are saying w is nothing but the first derivative, as well as dg is going to be df minus x w dw minus w dx, okay, right, and this is going to get cancelled. So, dg is nothing but minus x dw, okay. So, what you see when you look at this differentiation, okay, of f and g, we see the following, that the role of variable and its derivatives are switched between this function f and g. So, in other words, role So, in other words, role of variable and derivative has been exchanged. Variable of the original function is now derivative of the transform. Okay. Now, in order to recover the original function, what we do is we simply apply the Legendre transformation for one more time. Okay. So, to recover the original function, apply Legendre transformation for one more time. Okay. So, dg is minus of xw. All right. So, we are going to get a function g minus, we are going to say this is again f, the original function g, which can be written as g minus the variable is w. So, w times the derivative of that is del g by del w. So, this is going to be g minus w, and this is nothing but minus of x. So, you have g plus wx. So, this is how you are going to get back the original function. Okay. Now, having derived this, having said that, let us apply this concept to the function which we just did in order to show that simple integration does not work. So, let us again use the same function. So, the example is f(x) is equal to x square plus 2, f(x) is x square plus 2, all right, and w, in this case the derivative of f is 2x. So, what would be your g w or g as a function of w is going to be f minus the variable and the derivative of f, which is nothing going to be f minus x w. Now, f is x square plus 2 minus x is w by 2. So, we are going to write w square by 2, and this is going to be w square by 4 plus 2 minus w square by 2. This is nothing but minus w square by 4 plus 2. All right. So, this is your g of w. Now, in order to obtain, so this is our Legendre transformation which we applied to f of x. Now, in order to get back that we can obtain the original function, we are going to apply Legendre transformation to g, and let us see whether we are going to get back the original function or not. So, if we apply again Legendre transformation, so this is going to be, let us say, g plus x of w. That is what we showed here earlier. Okay. So, what is g here? G is nothing but minus w square by 4 plus 2 plus what is x? X is w by 2. Okay. And thus we are going to get w square by 4 plus 2, okay, which is nothing but, since x is w by 2, which is nothing but, we plug in here, this is nothing but x square by 2 plus 2, which is nothing but the original function. Okay. So, this is how we have shown that Legendre transformation is something which we can apply in order to change the variable, keeping the information intact. Okay. And now we can apply this Legendre transformation to thermodynamic functions. So, I will stop here and take it in the next lecture, application of Legendre transformation to thermodynamic function. See you in the next class.